One open port, that is all it takes. One misconfigured service, one forgotten database, one default credential left unchanged, and your server is gone. Today we are going to understand exactly how attackers find these openings, what port scanning actually is, and how you can lock down your own infrastructure before someone else does it for you. Every server connected to the internet has up to 65,535 possible ports. Each one is a potential door. Attackers are not guessing which ones are open, they are scanning systematically, automatically, continuously. SSH on port 22 is brute-forced thousands of times per day. RDP on port 3389 is the single biggest ransomware entry point in the world. Databases on port 3306 left exposed without a firewall rule have been the cause of some of the largest data breaches in history. And here's the number that should keep you up at night. Researchers have demonstrated scanning the entire IP4 internet, all 4 billion addresses, in under 45 minutes. Your server is being probed right now while you watch this. But what actually is a port? Think of your server as a building. The IP address is the street address, it gets traffic to the right building. But inside that building there are thousands of doors and each door is a port. A service listens behind each door waiting for connections. Port 22 is where SSH waits, port 80 is HTTP, port 443 is HTTPS, port 3306 is MySQL. Port 6379 is RDS. Ports run on two protocols. TCP, Transmission Control Protocol, is connection-oriented. Before any data flows, a three-way handshake confirms both sides are ready. UDP is connectionless and fast, it fires packets without confirming delivery, which is why it is used for DNS, video streaming, and gaming. Most services attackers care about run on TCP, because TCP tells you definitively whether a port is open or not. Here is how a port scan actually works. The most common technique is called a SYN scan, sometimes called a half-open scan. The attacker sends a SYN packet to a port. That is the first step of the TCP handshake, saying I want to connect. If the port is open, the server replies with SYN-ACK, acknowledging the request. The scanner immediately sends a RSD, a reset, to tear down the connection before it fully forms. This is stealthy because many older logging systems only record complete connections. If the port is closed, the server replies with RSD directly. No service is listening. And if the port is filtered, typically by a firewall, there is no response at all. The scanner times out. Tools like Nmap can run this process against all 65,000 ports in seconds, painting a complete picture of everything your server is exposing to the world. Let us talk about the ports attackers love to find. FTP on port 21 transmits credentials in plaintext, never expose it to the internet. SSH on port 22 is targeted by automated brute force bots every single day, use key-based authentication always. Telnet on port 23 is completely unencrypted, a relic that should never be internet-facing. SMTP on port 25, if misconfigured as an open relay, becomes a spam gateway. MySQL on port 3306, exposed directly to the internet, has been responsible for countless breaches. It should only ever be reachable from your application server. RDP on port 3389 is the front door for ransomware gangs. It should be behind a VPN always. RDS on port 6379 has no authentication by default. If it is exposed, an attacker can read all your data, delete it, or in some configurations even execute code. MongoDB on port 27017 became infamous for exactly this. Millions of databases were wiped and held for ransom because they were left open to the internet. Elasticsearch on port 9200 has the same story. When an attacker finds your open ports, they do not stop at knowing which ones are open. They do something called banner grabbing, sending a connection and reading the response headers your service sends back. That banner often contains the software name and version number. Now the attacker knows you are running OpenSSH 7.4 or MySQL 5.6 or Engine X1.14. They cross-reference that against public CVE databases of known vulnerabilities, and now they know exactly which exploits to try. After that comes credential spraying, trying default usernames and passwords for that specific software. Admin, root, saw blank password. This entire process, scan, banner grab, CVE match, credential spray, can be fully automated. Scripts on the dark web will do this against millions of IPs without any human involvement. The attack surface you expose is not just your open ports, it is everything those ports reveal about your stack. So how do you close these gaps? First and most importantly, default deny. Configure your firewall to block all inbound traffic, then explicitly allow only what needs to be reachable. If your database only needs to talk to your application server, it should not be listening on a public interface at all. Second, minimal exposure. Databases, caches, admin panels, internal APIs, none of these should ever be directly internet-facing. Put them on a private network. Third, if you need remote access, use a VPN or a bastion host, a single hardened jump server that is the only entry point to your internal network. Fourth, harden SSH. Disable password authentication entirely. Use key pairs. Consider changing the default port to reduce automated noise, though this is not a security measure on its own. Fifth, use port knocking for sensitive services, a technique where the port appears closed to everyone until a specific sequence of connection attempts is made. Sixth, and this one is critical, scan yourself before the attackers do. Run Nmap against your own IP addresses. See exactly what the internet sees. Knowing you're being scanned is the first step to responding. Your firewall logs will show SYN packets arriving at ports with no corresponding established connection, a clear signature of a scan. A single IP hitting dozens of different ports in under a second is unambiguous. Tools like fail2ban monitor these patterns and automatically ban offending IPs. SAD, the port scan attack detector, integrates directly with IPtables and alerts on scan signatures in real time. Cloud providers like Oz and Cloudflare have their own scan detection and absorption built into their infrastructure. And if you want to know immediately the moment anything touches a port that should never receive traffic, deploy a honeypot, a fake service that does nothing except alert when it gets a connection. Any connection to a honeypot is malicious by definition. There is no legitimate reason to touch it. Here is your 5-minute checklist. Right now, open a terminal and run Nmap with the SS flag against your own public IP. See every open port, then run with default deny incoming and explicitly allow only what you need. Run SSTLMP to audit every service currently listening on your machine and ask yourself whether each one needs to be there. Hunt down and remove every default credential, admin, root, blank passwords on databases. Finally, install fail2ban and set up alerting so you know the moment a scan begins. Network security is not a one-time configuration, it is a continuous practice. But it starts with knowing what you are exposing and closing every door you do not need open. Thanks for watching Sys Sketch. If this was useful, subscribe for more systems concepts visualized.